Good afternoon, everyone. Okay, good afternoon, everyone. I, Dr. Pranshman Parashar, co-coordinator of first 17 days refresher course. 2022 welcomes you in the first session of this refresher course. We are very blessed to have with us our eminent resource person, Dr. Pranjal Mule sir. So before starting our session, let me introduce our eminent speaker. Dr. Pranjal Mule is a systems and information technology professor with more than 15 years of experience. He has been a part of Vivekananda Education Society Business School, Chembur, Mumbai for the last 3 years. His area of expertise lies in information technology, big data, and business analytics. Professor Pranjal has in charge for computer labs, admission, MMS, annual event, research journal publication, and university exams in various PS schools. He is an active member of Business Analytics Cell. He has been SAS trained faculty for Data Integration Technology Data Warehouse. He is currently working as area chairperson in information technology domain of Vivekananda Institute of Management Studies and Research. Now, not taking much of our time, I would like to hand over the session to our eminent speaker of today's session, Dr. Pranjal Mule sir. Sir, please.
You can now start. Thank you, Professor Pranshman. Am I audible?
Yes, sir.
Okay. So good evening, everyone present over here, and we will start the session. I first of all extend my thanks to the Prestige Institute of Management Gwalior for providing me this opportunity to talk to you on business analytics, this very emerging area. So Professor Pranshman has already given my introduction. So currently, as he told, I'm working as area chairperson or associate dean of business analytics in Vivekananda Education Society's Business School, Mumbai. So we'll start with my presentation. Professor Pranshman, do I have permission or rights to present my screen?
Yes, sir. Please tell me if you face any problem, then I will allow. So are you able to share?
Hello, am I audible?
Yes, sir, you are audible.
I think I was disconnected for a while.
Yes, sir, you are disconnected. So are you able to share, sir?
Just a minute. Yes, I guess I can share. Okay, fine. Thanks. Is my screen visible?
Yes, sir.
Okay, fine. Thank you. Yeah, so as the topic was already assigned to me was introduction of business analytics and applications. We'll start discussing about this particular topic. And I have 1.5 hours. So in that, I will try to collate everything, whatever I have an idea and out of my experience, what business applications and what is business analytics over in this session. So the points which we are going to discuss during this session is what is business analytics. And in business analytics, we will specially stress more on data mining because this is one of the techniques for business analytics. So what is data mining? Then why data mining? Then different kinds of data minings which can be done. Then there are certain patterns. The technologies which are used in data mining, this is all related to business analytics because there are various techniques of business analytics, and one of the most popular and emerging techniques these days is data mining. Then the last two topics, which kind of applications and major issues in data mining, I skipped, rather I included the topics, although I have not changed in my points to be discussed, but I have changed in my presentation, and these topics are what are the major business applications in business analytics area. There are almost, almost all areas where in business analytics these days has touched upon, but we will take some major areas where business analytics is being used in their full swing. Okay, so this is what the. So somebody says that we are living in information age. I mean, this is very popular quote that we are living in information age. But in my opinion, do we really live in information age? In my opinion, no, we are not living in information age. Rather, we are living in data age. If you see all around us, we are all surrounded by data. And that data, today we are calling this only data term is totally lost. Now, today we are calling every data is a big data sort of. So today we are actually living in big data or data age. Information is something different. Information, when you process this data, then some pattern, some knowledge, some kind of, the insights which we find out of that data is called an information. But actually, we are not living in that information. Rather, we are all surrounded by data all across. So, to give some example, because now here I'm using the term big data, so definitely a business analytic, this particular topic is totally based on big data. So what all are there in that big data? So first we have to understand what is big data. See, this big data and data, these days people may use it interchangeably. Why? Because we actually are having big data all around, but there was a small difference. Earlier, maybe some 20-25 years ago, when computers started, and there was no emergence of internet. And even if there was an, the working or there was an penetration of internet in this society, but that time the social media and other kind of platforms were not available. So I give you the example to understand that big data, morning when we wake up these days, gone are the days when people used to wake up early in the morning, they used to pray God and, their own deities, and they used to start their days. But these days, when we wake up in the morning, very first thing which we take is our mobile, right? And the very first thing which we usually do is good morning. And this is a very common practice. I mean, all of us across, almost everyone present here, we do this way. We take up our mobile in the morning and we say good morning or hello for our all different groups which we are connected to. And it is not only you. The entire world is following the same practice almost. Now, this is the first point and very minute point which I want to tell you, that actually by saying good morning, we are generating data. And it is not only you, again, I'm repeating, rather millions and billions of people across the globe, they are doing it. So you can imagine what kind of data we are generating. This is one example. The other example, when we go and visit malls, big malls, like in your city, there will be big malls. Here in Mumbai, we actually visit several malls over here. So every mall, there's a common practice that there is a one electronic gate where we have to surpass, we have to cross through, and then one person with some handhold device, he used to, just to check across our body for some, what do you say, some critical or some risky equipments or something, if we are taking for the security purpose, in short. But do you really feel that whatever is being happened or whatever they do it and we cross through that security gate, it's only for security purpose? No, the other way around, if you see, it is not only for the security purpose, but the data which is generated through those devices can be used to see what is the footfall in that particular mall. So that probably can give them a better insights. What is the footfall, in which days, there is a high footfall, then what particular times, then there is more probability or the high probability of getting footfalls, what are days, what festive seasons, and so on and so forth. Data is same, only that security data, whatever is data is generated. But when we analyze that data, when we take that data for the further analysis, we can get better insights over there. And accordingly, that mall management or shop management or different shops inside can prepare themselves. When we get in, now this is the gate, now we go into the mall. When we go in the mall, in that vicinities, there are several shops, and you must have observed that the different places, security cameras, we call it security cameras, but they're basically CCTVs. CCTVs are placed, installed, even within shops, these are installed. So prima facie, it appears that they are all for security purpose. But again, within the mall also, it can further be analyzed which particular shop, which particular area, which particular zone is more crowded in which days, and what kind of shops people like to go over there, and many other things. So that indirectly, although this is all indirect, so there is a popular saying, your actions speak louder than words. So it is just like that within the mall premises, which shop, which particular area, which particular zone is being more visited by the crowd or the people over there. So that can also be analyzed by this CCTV data. So what I want to tell you, that whatever data, or by good morning or by CCTV, by security status, one more thing, it's all about, how should I put it? When you cross a particular area, suddenly some, the message comes to your screen. Suppose you have visited a mall a few days back, and suddenly after that, you're crossing through that area, and that road particularly, suddenly one message pops up on your mobile screen, that some discounts and for in particular shop is there only. So probably you might go to visit. So how it happens? You have not visited that shop now. You had visited that shop, and in that particular mall a few days back or a few months back, but now you're passing through, and suddenly that message pops up on your screen, on your mobile screen. So how it happens once you come under that vicinity of so these are all different examples which I want to tell you. These are all examples of analytics or analysis, whatever you say. But ultimately, the data which we are using is not a normal data. We are not transacting here directly. I mean, I'm just say good morning, the security gate, CCTV camera. Okay, inside shop, definitely we have transacted, but that is the only part, that transaction part, but all other data. Now, other thing, when you buy something these days, it's a new, what is the new mechanism or the new trend of buying anything. So before buy anything, we usually go to Amazon, e-commerce, and especially online buying I'm talking about. So when we go to Flipkart, Amazon, or any other e-commerce website, so we just first check the reviews of the thing. Even if we go buy physically in the shop, so first what we check is reviews of a particular product or a particular service. If we find good reviews, then we compare on the internet only. And after comparison, after reviewing and everything, then we take a decision whether to go or not. So what are these reviews all about? So they basically are your sentiments. So there are hundreds and thousands of people have already spoken about the product and the services, their sentiments. They have expressed out their sentiments over there. So you take those sentiments into account, into consideration, and then further take the decision whether to buy or not to buy. So what I want to say, that now this is again that whenever you put a review, you yourself sometimes put your own reviews about a particular product or a service. So these reviews which are coming, your social media, your Facebook, Twitter, Instagram, WhatsApp, whatever you are doing, you are adding some data to this entire world. And it is not only you, the entire world is doing so. So everyone is adding data to this entire data pool. And as a result, we are all surrounded by data, and all different types of data, wherein social media data, internet data, CCTV data, sense
Your participants, please wait for some time. There may be some technical issue from the first side. Hello, Pranjal.
Am I connected?
Yes, sir. You are reconnected.
Oh, is there any problem? Because my internet shows it's a strong signal. So I don't have any issue. I don't know why it is happening. Anyways.
Sir, please again share.
Yeah. Yeah, visible?
Yes, sir. It is visible.
Yeah. So I'm sorry, it's getting disconnected little frequently.
No, sir.
Apologies from my side. Yeah. So I was just talking about the different types of data. So all these data are collectively known as big data. So actually we are living in this data age. We are not an information age. Rather, whatever we do actually is helping generate that data. It is provoking that data to generate. And we are living in that information, in data age rather than information age. And this is all happening with that rapid advances in the storage and data collection techniques, which actually has enabled all organizations to accumulate that vast amount of data. The major challenge is how to extract information from that data is a major challenge. Okay. Our original normal old system, which we call it a traditional system, or that those tools, they did not have that capacity to accommodate and acquire that large amount of data, which is generated every day, those data sets, and find out some meaningful information from that. It is very difficult for them. So definitely we require some new kind of systems altogether. And these new kinds of system or new kind of ecosystems is called big data analytics or business analytics or data science or whatever you say. There are several names people are using it, that ecosystem. So big data analytics ecosystem. So humans, I mean, we all generate a lot of data every day. We have just discussed various examples across. And the data which is found, I think, on every drawer of the business. I mean, every company is using some or other kind of, just a minute. Yeah. So every business is using some or other kind of generating some or other kind of data. And as I told you, that data, almost all businesses are using some or other kind of application. So it is not only what we say in Hindi, bapauti of only technology companies. Rather, everyone is having the same rights of generating data, and they are generating it. So diverse businesses like life insurance companies, hotels, hospitals, product management, education, higher education I'm talking about, and many more. Just add names to this particular list. They are using data, they are generating data. Why? For better decision making, for better strategies making, and ultimately they want to improve their customer experience. All are using customer. If I talk about education, we also have customers. Students are our stakeholders. Okay, so we also want, parents are our stakeholders, academicians are our stakeholders. So we just want to, make that experience better and better and better. And for that, I need to use that data. For that, I need to utilize that data and to find out different patterns and find out different kinds of knowledge, extract out some different kinds of knowledge from that data. Okay, so this modern business marketplace is a data-driven environment. Let me tell you that according to one survey, I have not included that survey over here, but let me tell you one survey. I was just reading other day one article that across the globe, 90% of the companies have now realized that. I'm just telling you this recent research report which I read through internet only, that 90% of companies have realized that they cannot sustain without data. So they have to use this data strategies, data-driven decision making. If they don't do it, so probably their survival will be in danger. So now people and businesses are using those data which they are surrounded by, big data, and try to get maximum benefit of that data. So for that, they're using different technologies altogether. So the modern business marketplace is a data-driven environment. 100% agree. I am. Why? Because this is what the companies are all about. This is what the companies are. Gone are the days when decision-making used to happen on the gut feeling concepts, wherein more the experienced person, more have the better decision making, better have the decision making and so on. Rather, everything is fact-based these days. Everyone is data-driven these days, irrespective of age and experience and everything. If you have those skills, if you have that data, you just apply data models on that data, take out some good patterns out of that, and on the basis of that, you take decisions. This is what the entire world these days is doing. So data is definitely at the core, nearly every business. If I talk about just one example of human resource, so directors of those human resource, they are gathering data from different online resources. Why? To just find out what is the best fitment people for their capacities, whatever jobs they are available, whatever recruitments they have, whatever requirements they have, and what are the people which are available with their best capacities according to their educational qualification, according to their experience, whatever they have set the criteria. So they probably using these technologies, they can use it. Let me give you one example. I was just discussing with one company, and the company had a project. It's it's a business analytics thing. So they're using artificial intelligence technology, and they are in the process of developing a bot. What you say, it's a robot, or it's artificial intelligent equipped product, which will filter out, it's HR product, which will filter out those candidates. I mean, once they, publish the advertisements and everything, and online, when they start taking resumes, it will filter out those resumes which are most, fit for the requirement which company demands. So now no human resource or no human intervention, at least for this initial job. Only bot or the machine learning algorithms or artificial intelligent equipped programs, they will do that job for the human resource director. This is just a simple example which I'm telling you how business analytics is playing a big role in this area. So in short, data is everywhere. And now data is everywhere if we talk about, so definitely we are talking about the size of data. Once, let me tell you my experience. When I learned business analytics, so that time when, rather computer, not business analytics. So that time we used to learn bit, byte, then kilobyte. That was the maximum thing. Now today we are talking about big data case. We are talking about zettabyte. First we talk about megabyte, petabyte, yottabyte, and zettabyte. So these all different measures have come. I had never learned, never heard these different measures when I learned computer. But now these measures, which is a huge amount of data, you can imagine that we are talking about zettabyte over here, and it is giving there 21 zeros. You can see 1 zettabyte is equal to 21 zero. And if I talk about, for example, some 50 zettabytes, you can imagine what kind of data I'm talking about, what kind of size of data I'm talking about. So Forbes, you all know that Forbes is the company, and it's well-known company. So what the company says that almost 2.5 quintillion of bytes, which are generated almost every day. So that much of data is generated every day. And to our surprise, only 0.5% of entire data we are using for analysis. So you can understand what is the scope and what are our applications currently. So we have huge scope because we have huge data. if we use at least 10% of that data or 20% or 30% of that data, probably we will be able to achieve our target. But only 5%, 0.5% we are using, but still we are getting better results over there. So where business can use this business analytics or this data, I'm in short data, because we are talking about data. Core of business analytics is data. So if we use data, if businesses use data, so definitely business analytics will be there, because without business analytics, we cannot achieve the targets. We cannot achieve our objective, because we need to analyze the data, big data. And how it will happen? How will it happen? It will happen only we use the data in business analytics. So what areas where businesses can harness that data? So find new customers, social media interaction, and to track the customers' preferences, their reviews, their sentiments for different products and brands. Customer retention, yeah, this is very important. To retain the customer is one of the most critical jobs these days, task these days. Why? Because there are several ample of brands, ample of services, ample of products of the same capacities are available. So to retain the customer is the most critical job. Gone are the days when there are 2-3 products. So definitely customer loyalty that time was at high, it's a highest note. But these days it is not so the case. Why? Because everything is available in ample. So the customers may tend to switch to other product with the same capacity. This happens. So analytics is the only way to know in advance what customer is going to like, what customer is going to have sentiments or the behavioral changes and everything in advance, so that I can make those changes in my services and my products, so that I can catch hold of my customer. I can grip my customer. I will not let go my customer away. This is what I'm thinking. Then capture customers' inclination and market trends. This is which we have discussed. Then sales trends also you can, forecast is the major area of business analytics, descriptive analytics and predictive analytics. We are anyways going to talk about that, but this is one area which is there. Forecasting is very important and critical area, because every business wants a forecast, what is going to be there in future, and sometimes prescriptions as well. So that is there. And ultimately overall brand experience is improved. So these are all areas wherein business analytics within business can be used. There are only few areas which I have covered. There are many other areas according to different branches. So I've taken some few points, just highlights to give you a glimpse or to give you the understanding how business analytics can be used. One article by the same company, Forbes, it is said, or it is exhibited, that 49% of respondents said that analytics, this is all, from the business perspective. I'm just talking why business analytics so important in business areas, business applications or modern business. So 49% says that analytics helps them to take better decisions, wherein 16% say that it enables key strategic initiatives. Through business analytics, they could do it. And 10% say that it helps improve in relationship with both customers and the business partners as well. So when you compile it together, so you get almost 75% of businesses are in favor of using business analytics. Why? Because business analytics, utility of business analytics lies there for better customer relationship, better business partner relationship, help in strategic decision making, better decision making, and some new initiatives, new product development, new plans. They could do it with the help of business analytics, and they were succeeded in that. So this is what the success is lying over there using business analytics. And that is why, again, I'm trying to connect my previous statement with this statement, that 90% of the industries across the globe have realized that they cannot sustain without the business analytics. So now we come to the point, what is business analytics? So business analytics is not a software. First of all, it's don't misunderstand or just carried away with the concept that it is a software. It is not a software. Rather, it is a sort of discipline. It is a sort of practice. It is a sort of mechanism. Definitely, when I talk about practice, when I talk about mechanism, if I talk about discipline, so it imbibes everything together. So it is a sort of discipline or a practice which imbibes certain processes and technologies for solving business related problems. And for that, it uses certain methodologies to solve those business problems. It uses certain methodologies. And one popular methodology of business analytics to solve business problem is data mining, where we are going to talk about data mining. Although the predictive analytics, prescriptive analytics, descriptive analytics, forecasting, everything comes under data mining only. So although predictive analytics is especially written over there, but try to understand this is basically data mining. So whenever we talk about business analytics, so there are two terms. How to solve business problems? There are two ways. Either you use data mining technique, or the other thing, you can use statistical analysis technique. So statistical analysis, I think all of us must be knowing, because we are all management people, management faculty. We belong to management faculty. So we know research and we do research. So statistical area, we know different tests, different hypotheses, and the other statistical tools which we use to get inference from that data. But again, the other method for doing it is data mining, which is more of a machine learning technique. So data mining, machine learning, predictive analytics, this is one of the mechanisms to solve those business problems. So with this, we can analyze and transform your data into useful information so that better insights can be taken. We can identify and anticipate trends and outcomes from that data. Okay. And the ultimate result of everything is smarter decision making and data-driven decision making. So what are the major components of analytics? Okay, business analytics. So if we talk about analytics or business analytics, so usually data analytics and business analytics happens in two ways. First of all, whatever data you have, so you can go with a visualization technique to visualize that data. So data visualization is one of the major component of business analytics. But other than data visualization, because data visualization basically works on data aggregation. So it aggregates the entire data and then visualize your data with the help of different charts, with the help of different tables and different tables, and that too very dynamic, very interactive tables and very interactive reports. This is the one way of business analytics or data analytics. Now, business
Dear participants, please wait for some time. I think there may be some technical glitch.
Hello.
Yes, sir.
Just a minute. Yeah. Is it okay?
Yes, sir.
Yeah.
Yes.
Yeah. So the major components of business analytics, basically the data aggregation. Then for processing, it uses data mining, text mining, and definitely within data mining and text mining, it comes with association, which comes with forecasting or predictive analytics. So predictive analytics, forecasting, data, they all come, and association, they all come under data mining. But although there are different components altogether, text mining is a separate area wherein we try to find out the sentiments of people which is text analytics, text mining, sentiment analysis. This is the one field over there. Optimization to check, basically to optimize the the results by simulation technology, by some other technology, so that you can fine tune the entire processes and to increase the performance of the the efficacy of the organization entirely. And data visualization, as I told you. So data analytics, I mean, using data mining, analysis using data mining and data visualization using different tools like Tableau, the Google Data Studio, and there are many tools, these days available through which you can, even open source sources are very much available through which you can visualize your data. And RapidMiner, Weka, R, Python, what to name. I mean, there are many SAS, because SAS is one of the biggest company to provide big data analytics solution in this area. So SAS, and I was working with the SAS, one of the SAS products, and there were brilliant products. I mean, end-to-end solution, big data analytics solutions they provide. So there are different companies, there are different technologies which are there, and these are all major components which we can do under business analytics, and all are going towards one objective, to solve one objective, to provide better decision making to solve the business problem. So how it works, that we need to discuss, how business analytics or data analytics, because business analytics we talk about, so it's a business thing. Okay, we see the entire business in one, as a one major component, and in that, now we are going to solve the business problem. So definitely it will be solved with some of the data analytics techniques, as I told you. So how it happens? So first we need to see what is the business goal, what are the objective, what are the problem statements, what we want from that data analytics or business analytics techniques, that we need to decide. Then we set the method also, analysis method. Are we going to use any mathematical modeling? Are we going to use any statistical modeling? Are we going to use machine learning or data mining techniques or whatnot? So that we need to set. We need to check what techniques we are going to use. Then we take the business data for support that model, because we definitely are going to create a model. And once that model is created, then we apply that model. Definitely we'll check the model, the accuracy of the model, the precision of the model. We will check everything, the overall, the applicability of that model. Everyone, we do it. And once that model is approved, then we use it for our business data to solve our business data problem. And believe me, it will start providing you the results then and there itself. So we have a business data to support. So we take usually historical data initially to check and validate the model and everything. And once this is done, okay, then we apply the model. But before that, we also do something that whatever data, historical data, business only, which we are using, we will clean it, because cleaning of data is the major process, and integrating of data. Because sometimes what happens, your data is not coming from one source. There are diversified sources your data is coming from. There are diversified technologies your data is coming from. There are, the diversified sources and technologies. So once you start capturing that data, you need to clean that data and integrate that data into one platform, so that further you can use it. We will see one diagram over there further, which will get us the entire understanding how the data from diversified sources is being captured, kept, cleansed, and then used for the further analytics processes. So 80% of time actually goes in this acquiring data and cleaning that data. Rest is all very easy. I mean, you just create a model, apply the model, and your job is done. But 80 to 90% time basically is consumed for the data quality management, wherein data cleaning is one of the most important area. Now we'll talk about what business types of business analytics are there. So there are different types of business analytics. The first is descriptive analytics, predictive analytics, and prescriptive analytics. So we'll talk one by one. Descriptive analytics. Descriptive analytics, basically, The major question descriptive analytics is stood upon on what has happened. This is the main question. So it basically summarizes of all, the all data, the historical data, and gives you one indicator or one key performance indicator, which will help you to understand what has happened. The best example, our students' report cards, mark sheets, descriptive analytics. We don't usually use every day's report or every day's performance of all semester across the semester or what. Rather, there's one major component, the end-term exam, mid-term exam, different assignments, different activities. We compile it together, and whatever comes, the report or the mark sheet of a student is the descriptive analytics, which gets us a clear understanding, or even students a clear understanding what has happened. So that key performance indicators over there help them to understand whether I was at the lower side or higher side or mediocre side, and what I should do further. Okay, this is descriptive analytics. So Excel mein pivot table is the best example for doing descriptive analytics, because this is basically summarizing data. Whatever data you have, you summarize the data and you create a report, and this summarization data gives you the entire idea of what is to be done further. Then predictive analytics is all about what is going to happen. The major question, or the main question over here, is what is going to happen. Now, what is going to happen definitely is all about prediction, is all about the forecasting. Okay, so on the basis of historical data, it creates a model. Here we use data mining techniques to create a model, basically predictive modeling, forecasting. So there are different, maybe logistic regression. Yeah, to some extent it is forecasting, but basically classification as well. So linear regression and even regression techniques can be used for forecasting. So you use regression techniques and some other ensemble techniques to create different models. And through these models, you can forecast what is going to happen, what is going to be my sales of this products after 2 years, or after 5 years, or after 3 years, or next year, whatever. So I just want to forecast further what is going to be the likeliness of likelihood of my products to be sold, or the inclination of customers towards my products in future, maybe to the next year, or 5 years down the line, or something like that. So it's all about predictive analytics. Predictive analytics is very useful. Why? Because I'm just giving you some example over here, but it is very much useful in terms of healthcare industry. And prescriptive analytics also is very much critical and important in healthcare industry. This predictive and prescriptive analytics. These why I just let me quote one example. I had just gone one case study, I think last year or last year only. So that case study was all about it's case study about those premature babies. So premature babies used to be kept in, or they are kept in that incubation, and this incubation, which is the glass rectangle box made up of glass, wherein several sensors were kept, and they continuously monitor the overall health of that premature baby. So while doing it, so they collected, that research company or that hospital or healthcare industry, they collected hundreds and thousands of premature babies data, and when they analyzed the data, so they found out that this is all historical data I'm talking about, that on a particular heartbeat or heart beep or heart rate, and they just monitored that, and it was found that on a special type of heartbeat or heart beat only, it's heartbeat, speed of heartbeat, there are high chances that after a few days the premature baby may get a special type of infection. I don't remember that infection, but may get this type of infection over there. Now see what is happening. On the basis of this heartbeat, special type of heartbeat, there is a possibility, or there's a high level possibility that is going to happen. Now this is what is something which is that trend is it's surfaced out of it. So once this model is prepared and it is kept over there, it is deployed over there. So now healthcare doctors and those nurses who are serving those premature baby are very much on alert mode. So whenever that particular heartbeat comes, so their indication suddenly pops up, or it can pop up on their screen and can tell them that there are high chances that that premature baby can be infected by this special disease. So they are, preventive measures become easy because of this predictive modeling. Similarly, prescriptive modeling, in some cases, it prescribes also that what should be done in such cases. I mean, predictive modeling, it will simply predict what is going to happen, but in prescriptive case, it will also prescribe what is to be done, what kind of remedies, what kind of the precautions you can take. So this is what the prescriptive analytics and predictive analytics. All the predictive and prescriptive analytics is more popular in healthcare industries. To some extent, predictive analytics is, it's used in our normal, this normal industries also. But prescriptive, to give you a little, idea about prescriptive analytics, so probably you can talk about you can think about those recommendation systems which usually these social medias gives you. So social media have a recommendation engine which recommends you, like when you or e-commerce website, sometimes you buy something and it will start recommending you that it may be of your like, or even a YouTube or other social media, they may give it to this person may be of similar interest. It may be your friend, or you can do it, or something like that. So these recommendations, sometimes Google also recommends you what to do, what not to do. YouTube also recommends you. So these recommendations engines are nothing but a very, basic model of prescriptive analytics, but very basic, very basic. So these are predictive and prescriptive. So there are three types of business analytics models: descriptive, predictive, and prescriptive. So this is just, the diagram, what three types of data analytics are all about. Now we talk about the entire ecosystem of business analytics. So you can see that entire ecosystem, wherein one left-hand side is all about what are the data anchors. Data anchors are nothing but from where we can collect the data, we can capture data, who are the major data producers. So academics, industries, governments, civil societies, and all individuals and entrepreneurs, they are all big data generators. So from all these generators, we collect the data, and that data is not a normal data, big data. Once that data is there in the system ecosystem, then you have to analyze that data. And for analysis also, there are different capabilities required. First of all, the technology, big data analysis. I told you the normal traditional technologies cannot handle that large amount of massive amount of data. So you should have those special technologies which can handle big data. Okay, as I gave the example, Hadoop is the best technology ever heard, that it has that capacity to store and process the data. So all these big companies, if I talk about the Facebook, if I talk about the YouTube and the other companies, the backstage is all Hadoop. They are using Hadoop as their storage and as their backstage processing. Okay, so technology is required for any organization, and you should have data-driven culture in your organization. If your organization has that culture, then only you can easily deploy that big data analytics and business analytics ecosystem in your organization. Organization should always be in a learning mode. That should always have that status that organization is in continuous learning stage. Then only, because if you have the attitude of stagnancy, no baba, ab to main seekh liya, abhi aage kuch nahi, whatever I am doing is correct. So probably business analytics ecosystem is not made for you. So that you need to think. Then technical and managerial skills. So these days, industries also, I'm involved a little bit in placements also for my business analytics students. So whenever I talk to companies and interact with the companies, so I have now got to learn that now these days, industries and companies, they don't demand managers. They want techno managers who are good in technologies as well. Gone are the days when only managers who are making strategies and decisions based on those papers and reports and everything. Those days are gone. Managers should be dashboard managers who can see everything on dashboards, who himself can devise various dashboards for himself. He can see the data, he can directly fetch the data and take decisions accordingly. So that techno manager skills are very much required. So these are all, and yeah, besides that, the technology I'm talking about, so different technology, data mining technologies, the different model building technologies, Hadoop, R, Python, Rapid Miner, Smart PLS, or whatever. I mean, there are NIME, then PySpark, hell lot of technologies of business analytics are available, and people deploy these technologies to serve. DCB Bank has Hadoop backstage data structures completely, and they're using PySpark. They're using PySpark. It's a Hadoop system totally, and they have different interfaces like Scoop and Zookeeper and other to fetch the data from different RDBMS. They store it and they process it further to satisfy their clients, to satisfy their business customers. This happens. So customers don't know what technologies they are using, but I'm telling you because I'm connecting to DCB, I'm connected to DCB Bank, and I know how they are using this thing. And ultimate result is all about different visualization, then business change or social change, society change, because the perspective of society towards business analytics and towards day-to-day life is changed. And ultimately, it's a digital transformation and sustainable societies. So this is the complete business analytics ecosystem in a broader way, but in a shorter way, in a very focused local way. You can understand that extreme left-hand side is all data management, wherein I'm capturing data from variety of sources, diversified sources, and keeping it at one place. Then middle box is all about business analytics technologies, wherein once data is being stored, captured, translated in one format, can further be cleansed also, and can further be sent to the technologies wherein data analysis actually takes place. And last is all about visualization, which is nothing but here digital transformation. I mean, I can see the data, I can see the results. So data visualization is the third part. So this is a very local focused picture of business analytics ecosystem, and whatever is displayed on the screen is the broader perspective of business analytics ecosystem. So now, as I told you, that data mining is one of the most popular techniques of business analytics. So we'll talk something about data mining. So in earlier slides, we have already discussed that we are living in data age. We are not living in information age. We are generating 25 quintillions of data almost every day, but only 0.5% of that entire data which is there in that world, in this world, we are using for our analysis. So we are actually data rich, but we are information poor. We can call it, right? We are data rich, but we are information poor. So we require a technology which blends my traditional analysis methods with all high-end sophisticated processing methods for that large amount of data. Because see, I'm surrounded by, it's very much visible through this picture that that lady's who is standing there is all surrounded by data, and she's thinking, continuously thinking, how can I analyze this data? It is a big problem in front of her. So this definitely data not only it poses a challenge in front of you, but rather it provides those opportunities in front of, exciting opportunities in front of you for exploring and analyzing this huge amount of data and get new and newer insights from that data, or some trends out of you probably had never seen it. And this will become a miracle, and you being a business can easily sustain in the market. So as we had already discussed, that we actually are creating data heaps and tombs because we are generating data every day. And it is not only you, rather we all every business, every industry, every individual, every academia, every government, we have just seen the ecosystem. So all are data generators. So as a result, we are creating data tombs or heaps. But the problem is human capability is not so good, or that data generated or data heaps which are generated over a period of time, they are beyond capacity of human comprehension, right? So we cannot we cannot comprehend that data. We cannot analyze that data. We require technology to do it. And in parallel, those gut feeling decision-making which were there earlier, they were slowly became a little, what you say, it's out of fashion and rather out of date. Why? Because the data which is coming, so for decision making, the data is not used, gut feeling was used, so probably it started going all decisions wrong. So what we require, that we should use that data, entire data, or at least some part of the data for my decision making. I mean, companies should be data driven rather than gut feeling driven. So those days are totally gone. We have a data, we have surrounded by data, we are surrounded by those data heaps, and now it's high time to use technologies to use that data, find out different patterns from that data, find out different insights from that data, knowledge from that data, and then take decisions. So this is what the entire story. So what we want this. You can see from this picture, the lady which was totally surrounded by data, now she has an organization of the entire data. You can see how beautifully the entire data is arranged in a hierarchy. This is, it symbolizes that organization of that data, and out of that organization she is reaping, or she's digging out knowledge. So data is data, but what we are digging out further is knowledge out of it. So that is what we want. That is what every business wants. And that is what the entire story of business analytics. If you see, the left-hand side is all business, which is the heap of data. If we consider that as a business, so there must be some business analytics process, which is nothing but the set of disciplines and set of technologies, which will help me translate all my data into knowledge. That's the entire story, or that's the entire facts. Right? So data mining, basically, it's a process. Like business analytics is a set of discipline, so data mining is again a process or one technology or one methodology which automatically discovers the useful information from that raw data. Okay, so the beauty of this data mining technology is you can easily deploy this on large data sets, irrespective of the size of data. You can easily deploy that, and it will help you to find out different useful patterns out of that data, and these patterns will help you out. Okay, it also has a capability to forecast or to predict. You've just seen there are three types of business analytics: descriptive, predictive, and prescriptive. So it also has the capability to predict or to forecast. How? Just say, suppose we have a shop, or we have one agency or organization, whatever, and there is a customer who is newly arrived in your shop. So if it is a shop, and consider this is a shop, so what amount he will spend in that shop or that departmental store. So if you have already created a model on the different customers who are spending different amounts on different products, so on the basis of that model, it can easily be predicted through that model only, that this person who is coming newly first time in the shop, how much he will spend. Will he spend more than $100 or below $100? That can easily be forecasted. So it has that capability of prediction as well. So data mining, name is given data mining, but this name should have been KDD, knowledge discovery from data. Why I tell you, this name actually is very much similar to gold mining, silver mining, diamond mining, or whatever mining. So what happens actually if you go literally with this meaning, so when you dig out for gold, when you dig out from silver, so you will find pure gold and pure silver there. Okay, so you can easily separate it out from the dirt or from that noise, and you can easily separate it. But in this case, if I put it gold mining, so understand that separating gold through minings, you are separating gold from the other thing. But here, data mining, you are separating data from raw data. No. So basically, we are processing that data to find out certain information. So either it should have been information mining, but there is no information readily available everywhere. Data is available everywhere. So we cannot call it data mining. So we should have called it knowledge discovery from data. So actually, people call it data KDD process, but now the most popular and most word which is more in use is data mining only. So data mining is basically a very integral part of KDD process. Okay, so you can interchangeably use it, data mining or KDD process. But data mining doesn't mean we are mining data from raw data. It is we are actually discovering knowledge from that data. So this is the entire process. You can see the process. The bottom left-hand side is all about data, which we are capturing from various sources. We are cleaning it. We have discussed about data cleaning in the major components of business analytics. So 80 to 90% time actually is spent only on capturing data from a variety of sources, cleaning it, and then putting it at one place, and that is warehouse. So you can see the next left thing is, or the component is warehouse, where I can call it, repository. This is the repository, data repository, wherein I can putting all the data. Even today's data warehousing, although this is an old picture, so data warehousing concept still there in various companies, but the new concept has come as data lakes. So we are not talking here data lakes about, but warehousing is the concept wherein I am warehousing the entire data, putting every data into a pool, that pool. And once that is there, then we are using a section of data, because ultimately we need to set the goal. What is the problem statement of the company or the business for which I am to analyze the data? So on the basis of that problem statement, I will pick up only that data which is related to that problem from the warehouse, and I will use it in data mining. You can see the next component is data mining. So I will deploy the data mining practices or methodologies on that section of data which is captured or which is taken from the data warehouse. That will definitely generate certain insightful patterns and insightful evaluations or reports or whatever you say. That will definitely add to the knowledge. This is the entire process, and you can easily see the process all across the companies, all across the organization. And this is what the business analytics is all about. So in short, you can understand this is a data mining process. It is, the business neutral process. You can apply this process everywhere. So, but this is basically, this is an integral part of business analytics process. You acquire data, you warehouse data, clean data first, acquire data, then clean data, warehouse data, then you use data mining or some other analytical techniques on that data, and you find out results, or those results are maybe some evaluation, some indicators, or some good visualizations as well, which will give you the knowledge as a result. So these are the techniques which we have just discussed: data cleaning, integration, selection, data transformation, mining, pattern evaluation, and knowledge presentation. This is nothing but data mining, or you can interchangeably use it business analytics process. It is one and the same thing. Now, why data mining? Although we have discussed why business analytics. So that again is the answer for why data mining. Why we require data mining? Because we are all surrounded by data. Again, I'm highlighting that around 2.5 quintillions of data, or those bytes we are generating every day. Okay. So this is what I'm talking about. So that explosive growth of data volume, that actually has, is a result of because of that society is totally computerized. Okay, we have powerful data collection tools and data analysis tools, and for this all is attributing to generate that much big, huge amount of data, that gigantic data which is being generated, and all across the areas, from sales, from stock exchange, from products, manufacturing companies, for marketing, from customer profiling, and many other things, even customer feedbacks. So they are generating data, and this kind of data is being generated. So to handle this data, I should have some mechanism to hold that data, to deposit that data, and to analyze that data. And that mechanism is all about data mining. So these are all some facts. I will send you this presentation after my session. So keep this thing. These are all facts which will attribute why data mining is important, although we have already discussed these facts. So Google processes more than 20 petabytes of data every day, including around 3.5 billion search queries. This is what the latest Google processes, which I got it. Facebook, which is a social media platform, generates almost 4 petabytes data every day. You can understand the size of data which is generated almost every day. Okay, and for this purpose, we require a platform. So data mining basically turns the entire large collection of data into the knowledge. That is only one line answer of all this discussion, whatever we have done earlier. So data mining is an integral part of business analytics, because business analytics is a concept in which, or the set of discipline in which we are using certain techniques to analyze the data, and data mining is one of the techniques. So data mining technique converts the large collection of data into the knowledge. So what kind of data can be used? Can be mined? So all sorts of data. I mean, if it is a database data, I mean, whatever transactions you do, so these transactions basically saved in databases. Like we do online transactions, we go to ATM, we withdraw money, we physically go to bank, we transact, we deposit money, we withdraw money, even physical, but they all have a computer. So whatever transactions in offices, we place the order, we receive the order, all these things which are very much visible physically, although partly physically happening, partly computerized. So all these actions, all these transactions are happening every day. So these are all database activities. Then that data warehouses wherein all different types of data is being stored. So database se thoda bada hota hai data warehouse. I mean, in terms of size and in terms of different types of data also come in data warehouse, which is not database holds only one type of data, which is called structured data or transactional data. Wherein data warehouse can keep all sorts of data, audio data, video data, sensors data, this data, that data, all sorts of data, media data. You can hold it in data warehouse, including transactional data. So transactional data separately, you can use it for mining. Then all different kinds of data, like time series data, which is time related or sequential data, time series data, audio data, video data, spatial data, engineering designing data, hypertext data, graphical data, web analytics or web related data, which is generated through data. Google Analytics, you must have heard about it, which takes the web analysis, web mining basically. So all different types of data can be mined using data mining, and all come under business analytics. According to the type of business, you can do it. So there are different patterns which can be mined, और क्या होते हैं ये examples मैं one to one देता जाऊंगा. So there are different functionalities. These functionalities are very much responsible to mine different patterns in that data. So what are these functionalities? Characterization, discrimination, mining frequent patterns, association rules, correlation, classification, regression, cluster analysis, outlier analysis. All these are different functionalities, and all these are functionalities are covered under data mining. So you actually apply these functionalities on your data according to your problem statement. Okay, so whatever your problem statement, you apply one of the functionalities on that data, and you get the result. Okay, so these functionalities are divided into two tasks: descriptive and predictive. Descriptive ka matlab, you just want to classify your data. Characterization, general classification. Predictive requires, it imbibes the forecasting, future mein kya hone wala hai. Okay, from current data, you need to find out what is going to happen in future. So the basic two tasks are there, but these are the different functionalities. So we first talk about the characterization. What characterization is all about? So characterization basically is the summarizations, what pivot table do, or descriptive analysis, as I told you. So it is summarization. So this example is very useful, and it helps you to understand what happens in there. Suppose there is a customer relationship officer of ABC supermarket, and he wants to summarize the characteristics of all those customers who usually spend more than 5,000 rupees. Now understand, this is a 5,000 rupees, although dollar is given, in 1 year at this supermarket. So when he applies that summarization techniques or characterization techniques and functionality, so he gets the result, and that gets the result that the customers who spend more than 5,000 rupees a year in that supermarket, So they are basically from 40 to 50 years old. This is the age range for them. They are employed. They have excellent credit rating and many other features of these clients. So all these features, which are generalized features, they are totally anonymous. I mean, they are not irrespective of their names, caste, creed, features. These are all just the characterization or summarization of those people over there. So this is a generalization or the characterization functionality. So suppose your problem statement is like that, like what manager has a problem statement. So he just wants to mine that data, find out that kind of data. Probably he can take decisions accordingly. So he found out this result. Opposite to that is a discrimination, wherein I want a comparative analysis. And in this comparative analysis, maybe from there are two classes. I have an objective wherein I just want to see, the example is better. So there is an ABC Super Electronics. I'm taking ABC as a one name. And the customer relationship manager of this ABC Electronics wants to see. He wants to compare these two groups of customers. One group who is purchasing regularly computer products, I'm talking about, which is more than twice a month. And those who are rarely shop such products, maybe less than 3 times in a year. I mean, this is what. So he wants to compare these two groups together. So once he applies that discrimination functionality over there, so he found that 80% of customers who frequently purchase the computer products, they are aging between 20 to 40 years. Wherein the other group, he finds there are, and they are basically university, they are in university education also, who are frequently buying computer products. But the other group who infrequently buys the products, who are either senior citizens or youth, and they do not have any university connections at all. So this is a kind of discrimination it is found. Although looking at that data, you probably cannot find, but when you apply such functionalities, so you can get that entire picture in front of you. You can find out that knowledge from that data, and this is what is coming out of it. The third is association. Association is another technique to find out, or to discover something from that data. Again, a data mining technique. We just try to find out the association. I mean, it's basically the products which are usually bought together, sort of that, or what is the connection or the association of one product with other product. So suppose we just want to find out that what is the probability of, now here X is a variable. Don't feel that this is a mathematical expression, but this is how it is done. So X is a variable, which is any customer. So it gives you this result. I mean, this is what the result is all about, that the people or the students who are from computer science, they own a computer also, personal computer also. So this particular expression, major X computer science directs, or this derives symbol, owns X personal computer. So it shows that students who has computer science as a major subject, they also have personal computers. Now, what is the rationale for this particular statement? So it is given that there is a support of 12%. I mean, out of whatever transactions are there, 12% transactions wherein computer science is occurring, and the confidence level is 98%. I mean, all those 12%, at least 90%, the records are there of those 12%, wherein computer science and personal computers are coming together. I mean, the person who has majored as a computer science having a personal computer as well. So this is what the overall understanding. So this gives you the idea. If you have, you are an institute, or yes, you are an institute, and suppose you have some private programs, computer-based private programs. So probably you may think that if there is a good support and there is a good confidence out of this rule, so you probably may offer them that if you take this computer science as a branch, so probably laptop can be given to you. I mean, I'm just giving you the example how business strategies can be made out of it through this association rule. And this is all done from my past data. The other example, if person buy computer, so he also buys software. This is a rule. So this is given a support of 10%. I mean, out of all transactions, 10% of transactions are those wherein a person buys a computer, also buys software as well. And the confidence for this, out of that 10% transaction, there are 50% transactions are there wherein computer, the person who bought the computer also bought the software. So this is the confidence. So this is association, which is usually done through a priori algorithm in data mining technique. Again, giving you the better insights for your business, maybe for future, or maybe for just a classification or discrimination or characterization of your, the current situation, so that you can make better decisions, you can make better strategies further. Classification is all about creating a model on the basis of the earlier data. And through this, you can easily categorize the products. So basically, it is a categorization. So again, example, there is a sales manager of ABC supermarket who wants to classify whatever data he has in a supermarket data into three categories. The out of that sales campaign, he's driving some sales campaign, and out of that 3 responses he got it. So he wants to categorize what kind of sales campaigns are got it, or the response he got it. The good response, mild response, and no response. Out of this data, he wants to derive a model, and this model will be based, I mean, whatever model he wants to make that model for good response, mild response, and no response on the basis of which item, I mean the descriptive feature of the item, कौन सा item purchase किया है, price क्या है, brand क्या है, कहाँ वो item purchase हुआ है, उस item का type क्या है, और उसकी category. I mean, definitely category is going to be these 3 categories altogether. So now, on the basis of item, on the basis of price, on the basis of brand, on the basis of price made and its type, he wants to create a model कि कौन से price का item, कौन सा item, कौन से brand का item, कौन सी जगह पे खरीदा गया item had a good response, mild response, and no response. He wants to classify the entire data. And once that model is created, probably he will be able to understand which particular place, which particular brand, which particular price gets a better response or mild response and no response. He can easily distinguish that, and probably his further business strategies according to that. Probably he will customize his sales campaign further. He can tweak his sales campaign further also. Regression, unlike classification, is just to classify the data, but regression to forecast something. Okay, and it is usually done on numeric values or continuous data. Classification basically done on the categorical data, wherein there are 2 types of, and yes, no, male, female. I mean, both values are totally distinct values. I mean, there is no connection, but numeric data, I mean, there is a connection. It's a continuity in the data. So regression model are usually created, and it is very much useful for, to forecast some valuable, for some valuable area. For example, stock exchange, for example, sales revenue, for example, risk. So these are all different areas or sales wherein forecast is very much required, and all are numeric values altogether. So this helps you to, yes, yeah, Mr. Ravi Thapak Sharma, he raised the hand.
Ravi, can you please send your message to me personally so that I can ask the question on your behalf? Yes, sir. Ravi, please send your message to me personally.
Yeah.
So, yes.
So predicting categorical responses labels. Now here, what we want, maybe a same manager, the earlier example, sales manager wants to categorize the entire data, the sales campaign data, into good response, mild response, and no response. Now here, what he wants, he wants to predict the amount of revenue for each item. Okay, what kind of revenue is generated over there during the upcoming sales at ABC supermarket. So here, once he wants to predict the revenue further, so for that he is to take the earlier revenues, and through that earlier revenues, he can create a regression model through which he can predict the upcoming revenues as well. Okay, so through regression analysis, they can create a regression model, and that can predict the continuous value further. This is regression.
Sir, sorry to interrupt you.
Yeah.
The question by Mr. Ravi was, one minute. Regression example can be explained like trading, share marketing, etc. So he's basically asking that the example for regression can be like trading, share marketing. Or
yes,
this one?
yes, trading, share markets, and everything, wherein it is giving you the forecasting, it is giving you the prediction what is going to happen with those scriptures or those scripts further. It can, Ravi, can you hear me? So if it is forecasting that this particular script or this particular share is going to likely to go up or likely to go down, so this is what the predictive analytics altogether, which is put over there. So this can be the example of predictive analytics.
Okay, thank you.
Yeah. So the other patterns, whatever we discussed about the classification, there is another way of doing data mining, which is a part of business analytics, and most promising and most popular business analytics techniques. One is visualization, which is just to visualize data, and this is data mining. I'm just focusing more on it because more companies are wanting data mining techniques these days rather than only simple visualization. So clustering, wherein I don't want to label the data, I don't want to create any categories, I don't want to forecast anything. Rather, I just want to divide my data into different groups, and I then will analyze these different groups separately to find out what is the common in those groups, what are the behaviors of those groups. And once I find those similarities and those behavioral patterns of those groups, so probably I can go further for better informed decisions, or better informed decisions, or those indicators when I go with applying those clustering techniques. So I can then further analyze once I find out the groups, and then I will analyze what is common in those groups, what is the similarity in the group, behavioral similarity, spending, or anything, whatever we are, our problem statement is, and then we decide about what kind of action or what kind of decisions we can take it. So this is a clustering technique, and clustering technique is very, very useful usually in the sales campaigns. So wherein only a data is given, I just came across one example, and that example was BMW cars. Okay, so the data was given about BMW cars, and it was given to their sales teams, because BMW has 3 different variants. Okay, and they may be having more, but this particular data set was having only 3 different variants of BMW. And now sales team was given this data, and the higher ups wanted them to understand which particular brand is doing, what is the status of that brand, whether it is doing good or not, and what are the customer sentiments of these brands. And I want every brand or every way, brand, you can see different models of that BMW. If there is some sales decrease or increase, so what kind of business strategies we can do it further. So there was no labeling at it. Rather, company just wants to understand about their different car models, what is happening, the entire status, their customer inclination and everything. And so that they can accordingly devise their strategies. So in this particular case, the business analytics, I mean, especially data mining, the clustering method of data mining can be used. Believe me, there are 5 different clusters which are created, and every cluster has a different unique feature. The first cluster, second cluster, third cluster, fourth cluster, and 5 cluster. All these 5 clusters were not based on the car variants, rather than it is a combination of the user behavior. It is a combination of which particular model they like most. What are the other traits? Whether they go for finances, they go for online visibility of the different models, or they visit dealers, or they visit showrooms, which particular car model they see, whether they want some financial aids over there, or they purchase it lastly or not. So these different 5 different clusters exhibited 5 different sentiments, or 5 different behavior totally. So then company decided that there are few which actually the cluster with very minimum the data or observations. So they simply cut off those data sets because they were of no significance at all, because only few records were there out of that huge data set. So definitely, if it's 1,000 data sets, and if you're creating cluster of only 5 observations, it will definitely not impact on that, because my population is 5 records. So how can it impact on 1,000 records? No. So that small cluster was difficult to be significant. So it was totally knockoff. But the other patterns were the other clusters who are actually significantly very influential. So those were taken, and the different results which are coming from those clusters then can be further used by the company, or used by the company for different marketing strategies. There were few customers who are coming, who are visiting websites, who are visiting dealers, showrooms, more interested in a special model of BMW, but they don't purchase anything over there, but they don't even finance. I'm just giving you this example because I have gone through this case study. So then company use a different marketing strategies for such customers who are visiting frequently, but they don't buy anything. So probably some different strategies to translate these customers into sales is important. Other customers, there were 100% purchasing, but or 50% or 70% purchasing, but they were inclined to only one model, which is a very basic model. So how to tempt these customers to some other models also? There are different strategies altogether. So all different 3-4 clusters were analyzed further, and different marketing strategies then created. So this is what the most useful method for clustering or group your data, and then analyze every group separately and devise strategies, business strategies on those different clusters or those groups, so that you can get most benefit out of these clusters, and you can sustain in the market. Outlier analysis, basically it is used for fraudulent or criminal activities to find out. Outlier analysis, it is very very useful for criminal to find out criminal, or to to tap those activities, to locate or to pinpoint those activities. So outlier, everyone knows, who are all honorable teachers are there, so they all know what is outlier. It's an extreme values basically, which in statistics also, which doesn't come under bell curve or normal distribution. So those extreme values are called outliers. So analysis of those outlier values is very important, because it depicts your extreme behavior. So maybe it may not be you as a customer, somebody else is doing by hiding himself, or it's just fishing himself. So it may happen. So for that reason, this outlier analysis is very useful, because it uncovers various fraudulent usage, maybe of credit cards, by detecting what kind of unusual purchases are happening suddenly, because you have a pattern of Like whenever I go to ATM or for purchasing, I have a pattern. It's all decided by my own. So I have a pattern of buying and things, items in a particular range of my expenditure range is very fixed. I usually purchase in that particular band. And suddenly one day my expenditure limits shooted up. So definitely it's an outlier for me. And probably it may not be you. So suddenly my bank person will call me and he will ask me, hey, is that you? Are you buying it? So then I will have to confirm, yes, I am there and I'm buying, I'm using this credit card or something like that. So they continuously monitor those purchasing or some other activities or monetary activity which are happening. And whenever they detect any outlier, I mean, they don't have to sit on the computers, rather the computer has those processes, backstage analytics processes that are continuously monitoring. And then suddenly such messages and alerts pops up on their screen and then call and they check and confirm. So this outlier analysis is very useful in those, especially finance and the other criminal activities. Security, detective branch, police, they are using outlier analysis. Which technologies is used? So data mining, again, is not, it's a one word or one particular technology, rather it is an amalgamation of various things. It uses statistics, machine learning, pattern recognition, database, warehousing, applications, high performance computing algorithms, and many more. So they are all amalgamation of all these technologies together in data mining. Machine learning and data mining is one and the same thing. People use it interchangeably and there is no harm, because I also teach data mining with the help of machine learning, and people understand that data mining is nothing but the machine learning. There are two types of learning. Supervised learning is basically nothing but the classification, which we have seen. We have to categorize it, label it. And unsupervised learning, where I don't have any category, I don't have to divide or classify the data. Rather, I have a data, and then I need to understand that data, what we did in clustering. So that is what the unsupervised learning. So what kind of applications are targeted? Basically, those applications which are targeted are business intelligence applications. So again, business intelligence is a broader term wherein you are making your business intelligent. Okay, so this business intelligence actually imbibes everything, encompasses everything within it. So business analytics actually is a part of business intelligence, and data mining is a part of your business analytics. So this is how the entire story is all about. So you're making your business intelligent by using all business analytics set of disciplines and technologies which are there. So they're in business is becoming intelligent, sort of that. Okay, so it uses historical data, it uses current data for predictions and for classifications of data. The other is web search engines. Again, it's a data mining application wherein recommendations, basically, if you have your website and if you want to analyze your websites as well as a business, if you have your websites, analyze your business. So probably this can be used. Now, how business analytics, different applications in the industry. Sorry, I'm just completing. Give me 5 more minutes. I know that I'm running short of time and I'm out of time, rather. It is 17:15 already. Sir, can I borrow 5 more minutes?
Yes, sir. Sure, sir.
Yeah, thank you. So business analytics and industries, what business applications of business analytics are currently being utilized that we are going to discuss. We have talked about business analytics and especially data mining in business analytics. Now, most common applications I have included over here. First is credit card companies. So credit card companies, they continuously monitor your activities, your expenditure activities. Okay, and they gather that information. What are your spending patterns? What is your overall financial situation? Which demography you belong to? What are your lifestyle preference? Because you are using that card in shops, malls, movie theater, normal grocery shop, wherever you go, you use. So it gets them the complete idea about your lifestyle preferences, your demographies, financial situations, and many other things. Okay, so this is the one most important business analytics applications. The other is CRM, customer relationship management. We had already discussed in the beginning that retaining the customer is the most difficult task for any company. But if you have business analytics practices, so definitely the system will help you analyze with the help of those performance indicators only, that about your customers, which demography the person is there, their transaction patterns, what is the socio-economic information about the person, his lifestyle and anything. So probably on the basis of that, you can retain your customers better if he belongs to a particular religion, if he belongs to a particular, if he holds a particular lifestyle, if he holds a particular socio-economic status, he has a different buying pattern altogether. Probably once you read it, you can offer him better services. You can customize his services and offer him. So he may become a customer, company loyal or loyal customer to you in short. Financial companies are using business analytics like anything because it's a volatile place. Everything is changing very fast, rapidly over here. So it helps you to extract insights from that volatile place, and it's real time, on the real time basis. Okay, so this information companies are using to optimize the various aspects of financial domain like budgets, banking, financial planning, forecasting, portfolio management, and many other things. So it is very much useful in financial. And you must have heard about fintech, which is a new domain which is coming up. So fintech is nothing but financial technologies, basically nothing but all these business analytics applications, data mining models, forecasting models, classification models, clustering, all techniques of data mining are used to create different models and then predict, forecast, and classify the data which is there in financial domain. Human resource is another area wherein business analytics is very much used. I have given you one example. Similarly, this HR practices they are using, and they are finding the best fit people between companies, and the candidates. So I have given you the example of bot, which is which is created, and it filters out the initial the applications or emails for that particular positions automatically, and HR will get only those applications which are the best fit for that particular job on the basis of their qualification, on the basis of their history, experience, and the other things, the technology and everything. And only those candidates will be interviewed further. So this is how the analytics is helping them backstage as well. Manufacturing industries is the most critical and in terms of business analytics applications, because wear and tear in manufacturing industries is a normalcy. Because continuously, all these machines are continuously working over there. So maintenance is the major part of this particular industry. Analytics, business analytics with the help of IoT. Now I'm using the word IoT, Internet of Things. Basically, there are nothing but the different sensors which are put along with all machines on those assembly lines or those different machines which are working across the organizations. They are continuously monitoring the health of different machines which are working 24/7. And they're providing that information to that data repository, and those analytics models are continuously analyzing that data. And wherever they find that this particular equipment or this particular machine or this particular device is now about at the verge of maintenance or at the verge of malfunctioning or at the verge of destroying. So they will alarm, or they will they will inform the concerned person or the analytics people in advance, so that precautionary measures can be taken, and the sudden breakdowns can easily be prevented over there. So this is what the analytics is happening and is being used in manufacturing industries. Marketing, which advertise campaigns more effective, how social media, social media penetration is effective or is not effective. That is what what are the customer views, whether they will like the new product or will not like the new products, about the commercials as well. Many other things. I mean, almost everything, whatever questions you have in marketing, you can easily measure all these, the questions with the help of different indicators. And these indicators will tell you what to do in this area or not. So these are all different applications. I have only selected few applications because of the crunch of time I have. And I hope that I probably would have covered everything in the business analytics, right from big data to different business analytics applications in my presentation and my discussion. Thank you very much. I end over here.
Thank you very much, sir, for providing such an insight into this topic of business analytics for management decisions. Because earlier I was only having this kind of information that the business analytics is used for the kind of analysis for any data, that a data is given and we have to do some analysis. But a deep insight has been given by you, and how the business analytics can help in retaining the as well as attracting the new customers, as well as the better customer relationships and strategic relationships. Also the analytics part like descriptive, predictive and prescriptive analytics, which you have given, along with the examples of the case studies like the premature baby, the case study of the premature baby and other examples also. And the aspects related to the data mining, that how one can actually mine the data so that some valuable information can be provided, and aspects related to business intelligence, web search engines, and also in the last, the applications that you have provided with respect to the domains of in the industry like finance, manufacturing, marketing, etc. So we are very thankful to you, sir, for such an insightful session. And if you allow us, if there are some query by the participants, then they can ask. So participants, we are having, sir, if you allow us.
Yes. Either I don't know whether you have time or not. Otherwise,
take the query for 5 minutes. If there is any query, then they can ask through the chat box.
Yes.
Some of the queries we may take, and then.
Okay.
And meanwhile, I will send the attendance link. So participants are requested to fill that attendance link, because that attendance link will be valid for the next 15 minutes only. Okay. So if any query is there, please. Then you can ask, and PPTs will be provided. Okay, RK Premaji, please, can you write your query? Can you send your query to me? Okay, so I have sent the Google link to everyone, and in that you can write your attendance and can write your feedback also. If there is no query, you can write your feedback, as some of the participants have given their feedback that it is an excellent session and they want to have the PPT, sir. So
I'll send. Just let me send PPT over here only. I think, can I send in the message box over here on the chat box only? I can add, right?
Yes, sir. You can send the PPT to me as well. I will send the PPT.
Okay, fine. I'll then send it to you across.
Okay. RKG want to get unmuted. Okay. You can unmute yourself, Prema sir.
Yes, sir. So good evening, sir. And really thank for the interesting insight. Sir, my question is, I'm into teaching profession, and how can one be like, there are n number of softwares which are coming up day in and day out. And to start with, being in order to be wise, which kind of platform is good for a person who's into teaching, sir? Who's more of using social analysis? Because earlier I used to learn SPSS and then R and then Python is coming up. So in order to be so strong, basic statistical we are good in, but then what is your insight on that, sir? Can you please share your input?
Yeah. So see, according to me, we should always select the technology or a platform which has a wide band in terms of utility. See, when I started, I give you my example. When I started data mining on Weka. I have learned Weka. I think you must be using Weka, or you must have used Weka as well. But Weka has its own limitation as far as the academics are concerned. To show examples of supervised and unsupervised learning association rules to your students, Weka is a brilliant platform. But I definitely cannot do the big projects through Weka because it has its own limitations. Yeah. So then the R also comes. So if you see the many institutes these days, R also is being taught over there, and faculties are using again R. But as I told you that I am connected to placements as well, and to my understanding and to my experience, I have found that most of the companies, they are using Python, and they are preferring Python more on over other platforms. I mean, if I talk about for visualizations also, they use Python. Nowadays, Power BI is also being used. So, but why Python? I tell you, R has its own limitation. R is basically for statistical research. Machine learning techniques cannot be applied that effectively in R, which you can do it in Python. So Python has a very broad band, or the wide band, in terms of analytics. I mean, you can write a simple summation of two numbers, still IoT and deep learning, artificial intelligence, neural networks, machine learning, everything, even statistics, whatever you want, you can easily do in Python. So according to me, if you go with a Python, because the industries these days coming, they are also demanding people more on Python and some visualization tools. So I think Python is the best tool, according to my opinion, according to my understanding, which is to be taught to students, and we also learn Python. That is what my take.
Thank you, sir. Thanks for the clarity, sir. Really, I was a bit confused.
Yeah, you are muted, Prema ma'am. Sir, you are muted. Ranchuman, sir, you are muted.
Thank you, sir. Thanks for the clarity. Actually, I was a bit confused, and I used to get this question from my students also. And which one should we start with? So I just got a good clarity from you. Thanks for the input, sir.
Thank you. Thank you.
Sir, one more question from Itilekha ma'am.
Yeah, Itilekha.
This will be the last question. Yes, Itilekha ma'am, please. You can.
Yeah. Now I can. Okay. Good evening. I'm really thankful. Very wonderful session. But I have a question. So it is regarding the prescriptive analytics. Okay. So which like in predictive analytics, you talked about regression. You talked about logistic regression we use. So for prescriptive analytics, which are the tools that can be used? Or is it just like some recommendation or something like that?
Yeah, to answer your question, ma'am, prescriptive analytics, basically the recommendation or recommenders which are, are prepared with the use of collaborative filtering. You must have heard about collaborative filtering. Have you?
Yeah.
So these collaborative filtering is a part of that prescriptive analytics, and it is used even in big applications. I'm not, since I teach classification, I teach regression, I teach predictive and, descriptive analytics basically. But these case studies I have also gone through, and even the healthcare industry, as I told you, prescriptive analytics is more used rather than in some, the other area. Only that the social media which are using this recommendation engines. And even actually I'm working on a project, but I have not come to that end, wherein we are actually trying to create, along with my students, I'm trying to create one academics, specialization selection recommendation engine on the basis of this only. So we basically are using collaborative filtering. So what I found that collaborative filtering is one of the concepts which can be used, or this technique can be used in prescriptive analytics. There may be some other techniques which can be used for prescriptive, but I am not sure about it. But yes, if you want, so probably I will get back to you. You take my mail ID from Pranchuman sir. You raise me the query. I'll give you everything in detail for prescriptive analytics.
Okay, thank you so much.
Thanks.
I will take the email, your email ID.
Yes, yes. You just take. So we'll discuss further.
Sure, sure. Thank you. Thanks a lot.
Yeah.
Okay. So thank you very much, all of you. And thank you very much, sir, for this wonderful session. And at the end of this session, we would like to present a token of gratitude to you. So that's a small token from our side, sir.
Thank you. Thanks.
We will send this words of gratitude to your email. Thank you very much, sir.
Yeah. Thank you. Thanks a lot. Bye-bye, everyone. Have a nice evening. Okay. Thanks.
Thank you, sir. And I request participants to please fill that attendance link within the next 10 minutes. Thank you very much. Thank you, sir.
Thanks.